Good morning to everyone. I'm Dr. Sumi MS. The topic of my today's presentation is importance of nanocomposites from Unit 3 Nanocomposites. On completion, the students will be able to explain about nanocomposites and understand the applications of nanocomposites in different sectors and also describe the critical factors involved in the design of nanocomposites. What are nanocomposites? Nanocomposites are multi-phase materials where at least one component has dimension in the range of nanometers, that is 1 to 100 nanometer range, and it can typically be a polymer or a metal or a ceramic matrix reinforced with nanofillers. So it comprises of mainly the matrix material, the nanofillers and an interface between both. So matrix is a continuous phase material which can be a polymer or a metal, and the nanofillers are the dispersed phase within the matrix, that is nanoparticles, nanotubes, nanosheets, etc. And it can be one dimensional nanotubes or fibers, or it can be two dimensional platelets like clay or graphene, or it can be three dimensional nanosheets. And the interface material is the region between this nanofiller and the matrix with altered chemical and physical interactions due to high surface area. This is a diagrammatic representation with a polymer matrix which is being dispersed with nanospheres. So we have the nanoparticles and also the matrix along with the interaction zones between both. Nanoscale fillers. Nanoscale fillers may be carbon nanotubes or nanoclays or fullerons, and it highlights certain geometric diversity as mentioned in the given diagrams. This is a comparison between a micro as well as nano filler distribution, and it illustrates better dispersion is available at the nanoscale range. So here we are comparing a micro composite material where the fillers are in a micro size, and the other one is a nano composite material where we are using nano scale fillers. Performance versus cost comparison, we can see that the nano composites can outperform the traditional composites more efficiently in terms of both performance as well as the cost of manufacturing. The main advantages of nanocomposites are given with respect to its properties. So when comparing with the mechanical properties, nanocomposites have higher stiffness, good strength, mechanical strength and toughness with low filler loadings. And barrier properties, nanofillers create a zigzag path for both gas as well as moisture, and also it has low permeability. Electrical and thermal properties, it has increased conductivity via conductive fillers being used as nanofillers, that is in the case of carbon nanotube, graphene and metals. Thermal stability, this has improved heat resistance and flame retardance from nano reinforcement materials. Multifunctionality, it combines structural, electrical, thermal, optical properties in a single nano material. So a single nano composite material has all the benefits of structural, electrical, thermal as well as optical properties being improved when compared with the other type of composite materials, and it is also observed to be lightweight, and it has high performance to weight ratio, and especially this makes its application in the field of transport as well as aerospace. Applications by different sector wise. So in aerospace and defense we have employed nanocomposite materials because it has lightweight structural components. Radiation shielding materials are being created, can be manufactured with this, and also corrosion resistant coatings can be given with carbon nanotube or graphene employed nanocomposites. Then it is having applications in automotive field, in manufacturing engine parts, body panels with enhanced strength, thermal management, fuel additives for bringing better efficiency and also reduced emissions. Electronics and energy industries, here conductive circuits, sensors, electromagnetic interference shielding as well as batteries, supercapacitors and thermal interface materials are observed to be the applications due to nanocomposites. And in the field of biomedical, controlled release drug carriers, scaffolds for bone and tissue generation, and also it has applications as antimicrobial implants. And in environmental applications, nanocomposite materials are employed in water purification membranes, heavy metal adsorption, as well as anti-biofouling coatings. And in agriculture, fertilizers and nano pesticides with controlled release and soil remediation can be obtained via various nano adsorbents. Then in the field of construction and packaging, fire retardant parent insulating materials and good packaging films with nanocomposites which have superior barrier properties. Then critical factors in nanocomposite design: filler dispersion and alignment. Well dispersed nano sheets, that is clay, graphene, etc., create efficient barrier and also has good mechanical properties. Interfacial compatibility: strong bonding between the matrix as well as the nano filler via surface treatments or coupling agents enhances better stress transfer. Filler geometry: two-dimensional platelets often outperform one-dimensional fillers, and hence this filler shape, size and orientation are having a better role in improving the performance. Processing techniques: methods like melt, blending, in situ synthesis, coating directly affect dispersion as well as the quality. Limitations and challenges of nanocomposites: uniform dispersion difficulty, that is the tendency to aggregate at nanoscale range. Then scalability and cost: nanofillers and processing require specialized and it often seems to be a little expensive techniques. Long-term durability and safety: effects of nanoscale materials under real world conditions and toxicity are still under study. And regulatory barriers, especially this is in the field of biomedical, food and environmental applications. Quiz questions on importance of nanocomposites. Write down the applications of nanocomposite materials in different sectors. What are the limitations and challenges of nanocomposite materials? Thank you.